Good morning. Today we'll discuss regression analysis. Regression analysis is an extremely flexible tool that can aid decision making in many areas like business. Regression analysis is the study of relationship between variables. For example, when we have variables like qualification, salary, and experience, all three variables can be discussed through regression analysis. It is one of the most useful tools for a business analyst because it applies to so many situations. The branch of statistics that studies such relationship is called regression analysis. Because why it is called as regression analysis? Because its generality and applicability. The regression analysis is one of the most pervasive of all statistical methods in business world, and it is one of the very important definition here. Regression can be used to understand how the world operates, and it can be used for predictions. It's the most important definitions will be coming frequently. Some potential uses of regression analysis in business include the following. When we raise more questions, we'll try to understand what are the variables can be discussed through regression analysis. We'll try to understand. For example, how do wages of employees depend on years of experience, year of education, and gender? Okay. Here we can understand the wages based on the experience, year of education, and gender. The other question, how does current price of stock depend on its own past values as well as the current past values of the market index? So here also we have variable like current price and past. And how does the company current sales level depend on its current past advertising levels? Here we have taken two important variables like sales and advertising. The advertising levels of its competitors, the company's own past sales levels, and the general levels of the market. So these variables can be discussed through regressions. And another one, how does the selling price of the house, here the selling price is one variable of the house, depend on such factors as the appraised value? Here another one, appraised value. Here selling price, another variable is appraised value of the house. The square footage of the house is another variable. The number of bedrooms in the house is another variable, and perhaps others. So based on all these features only, the selling price will be fixed. The appraised value can be varied. If we can estimate this relationship, then we better understand how the world operates. I told you this definition will come frequently. So better understand how the world operates and do a better job for predicting the variable in questions. For example, we cannot only understand how a company sales are affected by its advertising, but we can also use the company's records of current and past advertising levels to predict future sales. The primary objective of the analysis can also be predictions. There are several categorizations in regression analysis. There are several ways to categorize regression analysis. We'll discuss a few over here. One categorization is based on the overall purpose of analysis. Okay. Here the overall purpose of analysis. Based on the overall purpose of analysis, this will be categorized. In which there are two potential objectives of regression analysis. One is understand how the world operates. Second one is to make predictions. These are the two potential objectives in this categorization. Either of these objectives could be paramount in any particular applications. If the variable in question is employee salary, and we are using variable such as years of experience, levels of education, and gender to explain salary levels. And the purpose of analysis is probably to understand how the world operates, that is, to explain how the variables combine in any given company to determine salaries. So, for this is an answer. And more especially, the purpose of the analysis might be to discover whether there is any gender discrimination in salaries after allowing for difference in work experience and education. So once if you consider few variables, again we have to discuss whether it is going to affect another variable or not. So that can be done by regression analysis. The second categorization of the regression analysis is based on the type of data. Data also, what type of data we are going to take to do regression analysis. So based on that also we can categorize. So here we have two different basic types of data. One is cross-sectional data, other one is time series data. In cross-sectional data, we will collect the data. The data collected will be in the same period of time. For example, if you take 2000 data, all the data will be taken in the same period, 2000 or 2001 like that. But for example, housing and wages examples are typical cross-sectional studies. Housing, okay, if you go and purchase a house, okay, so at this time, what is the price of house? So at present, what is the wage of an employees? Okay, so these are the data which can be collected in the same period. But when you go for time series data, it will take a periodical data. Okay, so it involves one or more variables that are observed at several, usually equally spaced points in time. For example, if you take a stock price example, fit this description. The stock market. So, what is the present data? What is the past data? So, based on that, you can predict the future data. The third categorization of regression analysis involves the number of explanatory variables in the analysis. We have two important variables. One is dependent variable, another one is explanatory variables. Dependent variable is the single variable being explained by the regression. It can also be called as response variable or a target variable. In case of explanatory variable, these variables are used to explain or predict the dependent variables. So these variables can be defined as independent or predictor. So based on these explanatory variables, regression is classified into simple regression and multiple regression. Simple regression in the sense the name it implies there is a single explanatory variable. The analysis is called simple regressions. If there are several explanatory variables, it is called multiple regressions. There are important differences between simple and multiple regressions. Then it is the primary differences, as the name implies that the simple regression is simpler. The calculations are simple. The interpretation of output is somewhat simpler, and fewer complications can occur. Special cases of multiple regressions, and again we have to define a simple regression analysis includes a single explanatory variable, whereas multiple regression can include any number of explanatory variables. The final categorization of the regression analysis is of linear versus nonlinear models. Linear regression, the relationship between variables are straight line relationship. For example, if you take two variables, say in x-axis and y-axis, if you plot the curve, the relationship will be a straight line if it is linear regressions. In case of non-regression, that the relationship will be in curved shape. By focusing on linear regression, we are ignoring the many nonlinear relationships that exist in the business world. The term linear regression is more general than it appears. Many linear regression relationships can be linearized by suitable mathematical transformations. We take regression can be used to understand how the world operates, and it can be used for predictions. This is the correct definition for regression analysis. So regression can be used to analyze cross-section data and time series data. Okay. So what is regression analysis? What we can do with the regressions? What are the different types of data which can be used in regression analysis? A good way to begin any regression analysis is to draw one or more scatter plots. First, we have to draw the scatter plot. Then we have to find out the regression analysis. The scatter plot is a graphical plot of two variables on x and y. So, if there is any relationship between two variables, it is usually apparent from the scatter plot. So, if you take this example, the data for drugstore example, here we have three variables: region, promote, and sales. So we can take any two variables like promote and sales. If you draw the scatter plot for promote and sales, we can understand how this promotion can affect the sales. And same way, when you increase the promotion, automatically the sales will also be increased. Here 77, if it is 77, it can be 85. If it is 110, it can be 103. If you 110, it can be 102. Okay. So there is a random variation over here, but when you look at this 90, it is a huge variation. Here by giving 77, you are getting 85. By giving 90, you are getting 85. Okay. So after 90, you are getting huge. 95 to 103, 100, 98. So there is no, when you look at these two regions, two variable, so there is no linear variations. It is a random variations. Okay. So for this table, we'll draw the scatter plot. So if you draw the scatter plot, this points will be the data points will be like that. So here we cannot draw any straight line. Okay. So here the sales is in vertical axis and promote is horizontal axis. Here the sales, here horizontal axis is a promotion. So the large promotional expenses causes a large value. If you take here large promotional, if it is 120, there if you point out, this point will come almost 120, okay, or more than 110. Okay. So if you give more promotion, you get more sales. So any successful analysis does not necessarily imply that the x variable causes y to vary in a certain way. This is one possibility, but there are two others. Okay. The first, if the regression of y versus x is promising, it could very easily be that y causing x. Okay. So x causing y or y causing x. That is the causality could go in the opposite directions. But another one, second or more common, there could be other variables that are causing both y and x variables to vary. So apart from x and y, then we may have some other variable also to try to affect x and y. Thank you.